So my interests are obviously open source GIS and modeling. I'm also a QGIS certified instructor. So if you follow courses with me, you can also get the QGIS certificates. Today, 42 students from IHE Delft have received one. And we donate 20 euros to QGIS for each certificate. So that's a nice system. I'm also together with Kurt, an evaluator of the QGIS certification process. So we review if organizations have up-to-date and good quality material, but we also look at if the organization supports open source, and there are many ways you can support, not only financially. Today you also see my interest in remote sensing for hydrology and agriculture. And we will also touch the topic of spatial data infrastructures and open data, which I also do a lot of advocacy on in my projects. And we also touch fieldwork. So basically today's training covers all my interests, although we will not be physically in the field, but behind our computer, but we'll simulate some stuff. We will go to some place in Africa to collect field data. As mentioned in the introduction, you can find me on social media, subscribe to my YouTube channel to get updates about new videos about mostly QGIS, Python, PC raster. So the objectives of this training are that after this training, you'll be able to set up a field data collection project using QGIS and Mergin Maps. For crop mapping, we'll focus on that, but the skills that you learn can be for mapping anything in the field. And using different backdrops, background maps, both online and offline use, because you might be in the field without internet connection or bundles are expensive. And we will use satellite composite as a background, WaPOR data, obviously, and Openstreetmap. And you will learn how to use Mergin Maps in the field. So here a bit of an order of the presentation and the training is I'll first introduce you to FAO WaPOR. So you learn about what the data is and where you can find it. And then I'll make the link with spatial data infrastructures and OGC API. So you learn what that is. And that's an important thing because we need that to connect to WaPOR. And then also link that to QGIS and Mergin Maps that we're going to use. So we're going to make an account in Mergin Maps and start a clean project in QGIS. Then we add and configure the background layers, both for online and offline use. Then we'll create widgets for the survey layer. So widgets are the nice features that you then can see on your mobile phone, like drop-down menus or sliders or a picture frame. Then you learn how to synchronize the project with the cloud and the phone. And we'll focus also on some final adjustments. It depends a bit on the time, what I can show you. So central to this, except for the WaPOR data, is Mergin Maps, which is a product from Lutra Consulting, a very nice product which brings QGIS to your mobile phone. And it synchronizes or it works seamless with QGIS. But it's not limited to use with QGIS, and it's completely open source, although we will use today the cloud service, which offers limited megabytes for free, but all the software can be found on GitHub, and you can install it on your own servers and then work with it completely for free. It has interesting features, so about capturing the data with the mobile phone, view your location, communicate with external GPS antennas. You can capture points, lines, and areas, but also photos. You can scan barcodes and QR codes. Then the synchronization goes through a cloud service, and you can also collaboratively work on your mapping project. So if you're out in the field with a team, then everybody can map, and the system takes care that everything is merged together. And in case of conflicts, when people edit the same point, for example, then it will also indicate that, and that can then be solved. So all the changes are tracked. And today, the CEO of Lutra Consulting, Saber Razmjoui, gave a great talk on the QGIS Open Day, maybe you've seen it, about this track changes of data, because you can also use that without using the field app, but just for working together on a QGIS project, it will track all your changes. And then a lot of integration features, which are nice, and you can see that it's built on QGIS. Let's then move to the data that we are going to use. So that is FAO's portal to monitor water productivity through open access of remotely sensed derived data. This was a phase 1 project, and now it's in phase 2, but that's not so important for you. But what is water productivity, and why do we need to know the water productivity? In fact, we want to produce more crops per drop of water. We are in need of having food for the growing population. Population is still growing, and all the crops need water, and agriculture is the largest water user in the world. So it's very important to look at how much food we can produce with how much water and try to get that more optimal. And this is also a recognized target in the Sustainable Development Goal 6, where it is expressed as dollars per cubic meter, but you can also look at it in agriculture with output in kilograms per hectare per unit of water consumed. So here on the right, you see the equation, and both sides of the equation are important. So we want to increase the production, but we also want to reduce the water consumption. And this is very hard to measure in the field and have the reporting for countries. So therefore, we use satellites to monitor water productivity in a cost-effective way. And FAO WaPOR provides you that data for free to do the calculations. How does it work? The satellites, they measure the Earth, they observe the Earth, and then we produce all kinds of products based on the satellite information, and that goes into the WaPOR database. You will hear later that it's more an infrastructure, and with that we can calculate the variables for water productivity and water accounting. So all these layers are available in the WaPOR portal. The project's run by different organizations, so funded by Ministry of Foreign Affairs, and IHE Delft involved, INVI, and we have ELIF, VITO, University of Twente, and Water Watch Foundation. Just a slide with an overview of the data that you can find. What is important is that the data is available at different spatial resolutions. So the whole of Africa and Middle East is available at level 1, which we call level 1, which is 250 meters pixel size. Then there is a level 2 for partner countries at 100 meters, and then there are selected case studies which have data at 30 meters. So 250 meter is available for all, and we will focus today also on that data. And we also need to take care of the temporal resolutions, and there are several temporal resolutions available for different products. So we have annual data, we have monthly data, we also have decadal data, so every 10 days, and we have seasonal data for certain products. So there are many different products with all these different temporal and spatial resolutions that are available. Now I hear you thinking, if you're not from this region, like, oh, okay, that's very limited and my country is not there. Well, then we have some good news. We're starting to make WaPOR global, so it will be available also in other parts of the world. And hopefully we'll see more use and global uptake of WaPOR. So as already said, the WaPOR data is used for water productivity, but also for water accounting. And water accounting is a way of calculating the water balance in a river basin, for example. Here you see different reports for river basins on the screen, using remote sensing data. Because also that is very hard to report. What is the water balance and what are the main users? And we calculate that using remote sensing data, and we present that in different sheets. If you want to know more about that, you can use this link. I will share links later. We also use it for irrigation performance assessment. It's also very important because we can benchmark with water productivity data. We can see which areas perform well and which underperform, and can look at reasons for that, which can be management reasons, or it can be physical reasons. And we can also set targets for improvement. So that's also how WaPOR data can be used. We have many resources to learn more about WaPOR. I will show you the portal in a bit because we're going to use that, but there are also a lot of documents on the FAO website where you can read more about the methodologies, about quality assessments. You can find scripts and source code and the water accounting and technical reports. We have at IHE Delft a lot of open courseware available for you, so you can have a look at courses in English and Arabic. And there's a nice applications catalog, which shows applications built on the data and use cases. And talking about that, it's too late to register, but we are starting 30th of November with a hackathon, where teams will work on creating something for monitoring and evaluation of global challenges using the WaPOR data. And you can join the live streams online. It's too late to participate, but you can get inspired by looking at the events online on YouTube. You can find it on the YouTube channel of our project, and I'll also share the link later. And last year, or in the previous Mapathon, an alumnus of IHE Delft with her team was one of the winners of the hackathon, and they made a QGIS plugin for having WaPOR data more easily in QGIS. It's called the WAP plugin, and they will have a keynote during the opening event on 30th of November live on YouTube. So if you want to have a look at that, tune in. So I'm now going to switch to a web browser and show you WaPOR. So you need to go to wapor.org. Here, I'll paste it in the chat. So if you go to that website, you will find this opening page. Looks a bit different. I'm logged in. You can make an account and log in. That gives you some extra functionality. And what you can see here is the 3 different resolutions, spatial resolutions. So continental, national at 100, and subnational at 30. We'll focus now on the 250-meter data. Here we see the legend. We are looking at the gross biomass water productivity in 2021. Provides us a legend. And we can add there more layers. We can work with opacity, transparency. And we can also choose different background. For example, if we want NASA blue marble. And instead of countries, we can also look at basins, for example. Then what we can do is look at layers. So here you find layers. And here we can choose from a list different layers that are available. For example, we can look at actual evapotranspiration and interception monthly. And then we can choose a month. So this is the one for October. It's loading. And this is also what we are going to use in the app that we are going to create. It's this one, but you can choose another date from the drop down. And here now you can see that we have the 2 layers and we can switch between them. What we can also do is find a specific place with locate or add your own points. And there's here analysis, where you can select a point and create a point time series. So I can create a new point by getting a coordinate in there or use a saved point. You can also just click on a pixel. Now very zoomed out, but it's just a demonstration. And I can save this location to my account. And I see the values of the data that I'm looking at. And I can also go to point time series. And there I can choose a time period. And I can choose here longer period. So let's look at 2020 and then run the operation for that point. I chose the monthly, so it's taking a bit long. I had to do the annual. Maybe that was a better idea. Let's see if we can do it. Maybe it's a bit too much to ask. Let's see. Let's do it again, but now for a smaller one. If I want just this gross biomass water productivity, one time series, time period. Okay. And this should be annual. Maybe there are already some questions. Here we see a graph. We just have 2 points here. So that's what you can do. You can then also save the data in a CSV file, etc. So the website already offers some nice tools that you can use. But to have an overview of all the data, the most important button here is the catalog, because this gives an overview for the resolution that you choose of different data sets that are available. And we're going to use today this one, actual evapotranspiration and interception monthly. If I click on it, I get the metadata. So it gives here a description. If I click this arrow, I get additional information, which gives the unit, but it also tells me that I need to multiply the data when I download it by 0.1. That's important if you want to do calculations. So the data is scaled, it's for storage purposes. And it's always important to read the metadata of any data set that you want to download. And here you see the different months that are available. And if you use the download button, then you can download the TIFF file. You see in the lower left of my screen, the file name .tiff, and I can then download it. That's not what we are going to do, but I'll get back to this later. So I'll go back to my presentation. Because in fact, WaPOR is a spatial data infrastructure. I always teach my students that it's not that these things are not just databases. Databases was something we did in the past and which did not really work because you need more. Spatial data infrastructure, or SDI, makes it possible to discover the data. You can search, you can browse, you can use a search engine or a catalog. When you found some data, you can visualize it in an interactive way using infographics or real-time data. That's exactly what we have seen with WaPOR. You can also evaluate the data. You can read the metadata. You can find out the quality. And you can also access the data, but in different ways. We saw that we could download it, but we can also link to it through apps and services and through our GIS clients. And that's exactly what we are going to do for today's training. So it's much more than just a database. A database is only one part of it. And therefore, because it is a spatial data infrastructure, and it uses the Open Geospatial Consortium standards, gives us a lot of possibilities to connect to it. So the Open Geospatial Consortium is a non-profit organization consisting of many stakeholders, private sector, governments, academia, others, who decide on certain standards to use for exchange of spatial data. And you can see it as, in many countries. You come from all over the world here in tuning in our Zoom session, in our webinar, and you probably use different power plugs. And you know, it's a very difficult job to change all the power plugs in the world. It's some kind of national pride that every country needs its own power plug. But we came up with something smart. So we give up on changing the world that everybody has one type of power plug. But we use this universal adapter when we travel. So you can still plug in your laptop and other devices in the power grid of the country that you visit. Now you have to see the ODC standards in a similar way. It is for connecting to other systems without making one big uniform system, because also with GIS and other things, it's very difficult to change that people all use the same. But you have to see the ODC standards as an interface. And with computers, we call these interfaces APIs, Application Programming Interface. And how it works is that a client, that is what you use, it can be QGIS or a mobile phone app or a website, and the user indicates that he wants some data from somewhere, from another server. Then the client sends some message through the API to get data from the server. And this often goes via HTTP, so via a web link. And then the server responds, and through the API gets back the data to the client. So that's important. And one form of that is a REST API, which stands for Representational State Transfer. ODC has many APIs. In the past, we called them ODC Standards, which you can still find around a lot. The WFS is for downloading features, the web feature service. So it's for points, lines, and polygons. The WMS is for viewing data. It renders a picture, JPEG, PNG, or other format from raster and vector data. So you can just have a look at it, but you cannot interact with the data itself. But this is very useful for backdrops. CSW is catalog services for the web. This is how we can search in these infrastructures and store metadata. WPS is for programs that run on servers. WMTS is with tiles. We also use that a lot. That is the WMS is one big picture, like you saw with actual evapotranspiration and interception of Africas. The whole picture is there in one WMS, but you can also divide it in tiles, then you get a WMTS. And if you want to download raster data from a web service to also do calculations with, you need a WCS. Now, ODC is in a transition by moving all these standards to new APIs. So you have to keep an eye on it that these names will change. But for a user, it will not make too many changes, but it's more for developers that it gets closer to, gets the geo world closer to the IT world. Because these open standards or APIs exist, we can link our desktop GIS software and apps and services to such an SDI. And we use it for sharing spatial data, also for reading the metadata. And we can use SDIs also to share documents. And even we can manage users on such a system. So with their profiles, you can see what they've uploaded, and you can discuss and engage with each other. Because of these ODC APIs, we can also link our GIS, like QGIS, to such spatial data infrastructures. And if you have a look at the data source manager in QGIS, you find at the bottom this whole block of strange words that you might have not used yet. But here you recognize now these ODC APIs like WMS, WMTS. There's also vector tiles. This is a very nice way of sharing data through the web, where you still have the flexibility to style with colors and labels the layers. Yeah, that is a very useful feature that you should really try out using, for example, the MapDialer plugin in QGIS. I have some videos on my YouTube channel that the recent ones that show how to use vector tiles from MapDialer. XYZ tiles are also called raster tiles. Have a bit of a similar idea, but it's raster based, and it cuts your raster into tiles at different zoom levels to make it efficient to load into QGIS, for example, or in a mobile phone app. So here you see all the other ones. And in GIS, you can also connect directly to such a spatial data infrastructure. Here we connect to a Geonode, and then it will find all the layers that are available in that spatial data infrastructure. Geonode is a nice open source spatial data infrastructure which has PostGIS as a database, and it uses GeoServer for the ODC services. And then in this example, you can load the basin boundary of the Mara and then use that for your research. So that was the theoretical part of my presentation. If there are any questions, I can answer them from the chat. Otherwise, we'll slowly continue. So what's next is that we move to QGIS and start building our mapping project. So I made a clean profile in QGIS, so as if it's a fresh install. So you can see all the magic that will happen. And first, I want to see where we are in the world here. So I'm going to load first an OpenStreetMap here. Without any plugin, there is, I'm using now QGIS 3.28. Now here you can add OpenStreetMap simply to QGIS. And I've prepared a little study area. So, but you can choose, if you're trying to do this at home, you can use your any area in Africa, because we are still not global, that you want to use for today. So I'm just going to focus on this area. I made a special bookmark to search something that has some agriculture of interest. So I would like to have this OpenStreetMap available in a mobile phone app. And I would also like to have a nice satellite image as a background. And therefore, I'm going to use an XYZ tile from MapDialer, because they provide really nice tiles with satellite images. So I go here, and if you go to MapDialer, and put it in the chat, see your question from Thomas. Any hope of adding pollution data, CO2, CH4 in the portal? Well, its focus is agriculture, so unless it's important for agriculture, it could maybe be added. But at the moment, I don't think there's plans for adding CO2, CH4, or other pollution in the portal. But there are other portals where you can find that data. So I'm pasting here the website of MapDialer, and you can create a free account by clicking on this button. I already have an account. And you also need that account to use the MapDialer plugin in QGIS. But today we are not going to use the MapDialer plugin, but we're going to use MapDialer in a different way, because the layers from MapDialer through the plugin cannot be used in the app. They have another kind of authentication that will not work. I found that out the hard way. So I'm going here to my cloud, because I already have an account. I sign in with my Google. And what you can see here is then under under tiles, you find here all the tiles that are available. And I would like to use this satellite tile. So that looks really nice. And well, you see it's very smooth, and I can use this for any place in the world as a nice background. So that's what I want in my mobile phone app. And I want that later online, but I would also like to have it offline. And I'm going to show you how to do that. To use that, I need to copy here under raster tiles this link. It's cutting off a part of the link that you also should not see, because it has my key. So it has an API key. Only when you have an account, you can use it. So I'm going to copy that. Maybe you see that later, and then I'll also renew my API key. So here's API keys, and there you can also renew it. So I've copied the link. So I'm going to go here to XYZ tiles. I click right, and I choose new connection. And I'm going to write here MapDialer satellite. I paste here the link, then you'll see the key, which I will then remove later. And I'll click just OK. Now it's added here to the list. And simply add this to the project. And now we have a nice satellite backdrop. You see how fast it is. So that's super nice. And it's global. So that's really nice. So I have OpenStreetMap and I have MapDialer. And then, of course, we want WaPOR data in the background. But how are we going to do that? Are we going to download that? That's a bit old-fashioned, right? It's a spatial data infrastructure. So we could use maybe some OGC service for that. Let's have a look. Go back to FAO here. And we were here in the catalog, and I'm interested in this data. And I see here OGC link, and now you know what OGC means. So I'm going to click on this, and it will load in my browser, and I'll copy this whole link. You see here GeoServer. That is the piece of software that makes sure that the OGC protocols are used for serving the data on the web. And you see WMS. So you've just learned that that's a rendered picture of the data, which is good to use for a backdrop. So I've copied the link. Now go back to QGIS. And it's a WMS, so I need this one. So I click right, and I choose New Connection. And I call this FAO WaPOR. I'm going to paste the URL here. Normally, you only need the URL until question mark. But what QGIS will do is it will cut off the rest because we are linking directly to the GeoServer. So you'll see all the layers. You are not linking to a specific layer that we chose here. So we need to choose that later. So I paste it here, I keep it default. If it goes wrong, I need to truncate it. But if I remember well, it will be automatically truncated. Click OK. And now I see this little arrow and I can expand. And I expand this and it's searching now on the GeoServer web map service of FAO WaPOR. And there I see all the data that is on the server. And I'm interested in actual evapotranspiration and interception monthly. Because I want the last month, because I'm going to the field in our imaginary case. So, and I find it here. Actual evapotranspiration and interception monthly. Through this way, you will always find the last one that is in the database. So I do add layer to project. And it will load the whole of Africa, therefore it takes longer because it's not in tiles. And here we see it. If I hover my mouse over the layers, you can always see what we are looking at. And here you recognize the URL of the WMS, but you will also see here that it is 2210M. So you see somewhere, cannot show that with the mouse, I think. No. You see somewhere L1 for level 1, AETI, actual evapotranspiration and interception, underscore 22, 2022, 10, month 10, M monthly. And then a bounding box with coordinates and the projection. So that's what we have. So we have 3 nice background layers that we can use in our app. But this is just playing around with QGIS, because for making the app, we need to install another plugin, and I probably need to start from, or I need to start from clean again, which is no problem, because then you will see it again. So I start, I'll just start a clean project, and I'm going to install plugin. On the plugins manager, you need internet connection. You make sure you're at all. And there I'm going to install Mergin plugin to handle Mergin Maps projects. It's exactly what we want. So I install this plugin. Note that if you install plugins, there's always this link homepage that brings you to the documentation. So many of the plugins need some extra information to learn how it works. So you can always have a look there. Now what happened, it added a few buttons here. And it has added here a new feature in the browser panel of QGIS. And it says not configured. We need to configure this. And what we need to do to configure this is to make an account in Mergin. So I'm going to go to my mobile phone. Hopefully you can see it. And I go to Mergin Maps. And this was my rehearsal project, but I'm going to create a new one. So If you have downloaded Mergin Maps from the App Store, it's available for iOS and for Android, then yours is probably completely clean. But you can make an account, and you can create the account here from the app. So that's what you need to do. I already have an account, so I'm not going to create one, but I'm going to use the account credentials here for configuring the app. So I use here my account. Let's save the credentials and test connection. If it says OK, it means your account works. Yeah. So what I did, I made an account using the app on my mobile phone after installing Mergin Maps. So I think this will take you a little time, but try it. Maybe meanwhile we can get some questions at this stage, while others are catching up. Install the Mergin Map, the Mergin app, and then creating the account. If you install this on your own server, then you can create here a link to your own Mergin Maps server. So as said, it's all open source, but we are going to use here now the cloud service of Mergin Maps itself, and that gives you 100 megabyte space. If you want more, you can have a paid account, but if you can't afford it, but you're good with installing open source software, then you can also install it on your own server. Okay, I'm gonna slowly continue. So once you click OK, you get a message that the password is saved in your account of QGIS in your profile. And you can see here my projects, where your own projects will be stored, shared with me, with projects from others. And Explore, there's here around 3,000 projects made by others that are public, that you can read only and clone and work by yourself on it. So I'm going to create a new clean project, and there are these buttons here, and there's here Create Mergin Maps Project. That's what I need. And there are 3 options, and I'm going to use New Basic QGIS Project. Really starting from scratch, that's the safest way of creating a Mergin Maps project. And it will put it in my profile here. This is your username. So it will be visible for other users if you make it public under your username. And I will call this, let's call it tagng, so you can easily find that later. And you can change where it creates it. I'll just create it in my user profile that it by default gives. And then I do finish. And it initiates a new project as well on the cloud as here. And then I can start adding again those backdrops. What you get is already the Openstreetmap raster tile and a survey layer. So now I'm going to repeat a few steps. So let's go to our example area, and let's add from FAO on the actual evapotranspiration and interception monthly layer at 250 meters. And the satellite image that was on the XYZ. This is a DM, by the way, also very nice, but I need a satellite. So there's our study area again. And the survey layer needs to be on top. If you click right, you can choose move to top. And now it's on top. And I also want to have these layers offline when I don't have an internet connection in the field. So what I'm going to do is I'm going to create local tiles, which are called MB tiles. Therefore, I need the processing toolbox. And let's first save the project processing toolbox. And there you can search for X, Y, Z. And there are two options here, generate tiles directory or MB tiles. We use this. This is a file to store these kind of tiles. So I double click. So what you need to make sure before you do this is always make sure that only the things you want to make in a tile are in the map canvas. So I'm going to switch off other things first, just to be sure, but in this case, it doesn't really matter. But if you have other layers on top of this, like vector layers, it will also integrate that as pictures in the tiles. So I just start with the satellite image, and that will be the biggest one. So I want to use the canvas extend. So I clicked this button and I get a canvas extend. Note that I'm using just a pseudo-Mercator projection. Normally you would use the projection of your study area. Here you can give a minimum and a maximum zoom level. And I'm going to use 12 to 15. The problem here is that the more zoom levels you add, the bigger the file will be. And so it depends on your mobile phone storage space, and also for synchronizing the first time with the server, it will create a lot of space, a lot of traffic. So I'm just using 12 to 15 here. I keep the rest as default, and then I save this to an MBT file, and I will save this in the folder where we are running this project. And that is on C users here. So I will save them in the folder where my project for Mergin is saved. Make sure you put it there, otherwise it will not be used in your project. And I call this one satellite. Save it, and then I run it. This will take a bit. It will now download the tiles. Oh, it's super fast because probably it was small. Let's see. On the test, I did probably a larger part. So I'm going to load this. Let me make this smaller. So project home. That's a nice button where you see all the files in your project home folder. And I'm going to add these MB tiles. And I'm going to check if it looks the same. It didn't work. It was a bit too fast, too good to be true. Let's try it again. I'm not sure why. When I tested it, it worked. So I'm going to put this one up again and maybe zoom in a bit more to this area. And I'm going to just do it again for the extent. 15. Maybe 10 to 15, not sure. Let's delete this one first. I think there's an issue there. Okay, not sure why. Let's do the other ones first. Maybe there's an issue with the MapDialer server that it doesn't accept that. I have a backup layer. Let's do this one. So I'm going to create MB tiles. And for this one, I'm just going to use one layer because the pixels are 250 meters, so we don't need more resolutions than only this one. And I call this one ATI. And I run it. Seems something is wrong. Let's save and reload this project. This can always happen in live demos, of course. Let's try it again. Otherwise, we'll proceed with the online. When I tested this, it used to work. Maybe there's a hiccup. So generate MB tiles. Choose the extent. Yeah, set to current map canvas. That's okay. 12. Okay. Save file. Yeah, I see. Maybe I don't have permission to save. I don't think that's the case because I tested it on the same drive, just another name. So you can see that later. I can load the old project. Maybe it just got MapDialer just got it a bit messed up. Maybe because I tried a few times. Let's try it again and see what happens. Okay, this one worked. Now let's see if there's data in it. But at least if we run again, add to project, and I can already see that this one worked. So I hide here the other layer that was below. Yeah, so the MB tile, the offline one works. And I'm going to do the same for OpenStreetMap. And then I try again MapDialer, maybe it works, otherwise not. Okay, and I do this from 10 to 15. Call this one OSM. You can try to play a bit with the minimum and maximum zoom level, depending on the file size. Because this one, let's see, file properties. This one is still okay. It's around 6 megabytes. So I'm going to add it. So if I now hide this OpenStreetMap, then you see the offline one, the MB tile is also there. So now only we need to do the same for MapDialer satellite. Let's try it once more. Stand. Let's do it on the safe side, just for one zoom level. Okay. Okay, now it worked. There was probably a little hiccup in the internet. Yeah, here you have the proofs. This is the local file. I hover my mouse over it, you see where it's stored. So that works great. But now it's a bit messy with all these layers here. And the nice thing with Mergin Maps is that it also supports map themes to organize your data, your layers. And map themes are a nice functionality of QGIS to organize your layers. So what I need is the survey layer needs to be on top, but I want to use different combinations of these ones. So this one is the online satellite layer. So I'm going to save this theme to satellite online. So that's our first map theme. The second one will be satellite offline. Okay. And here we have OSM, OpenStreetMap, offline. And let's do this one next. Online. And let's then do this one. And this one. Okay, now you wonder what that was. Well, now I have a whole list here, and I can simply swap between them. And the mobile phone app will take that over. So the user in the app can then see these different options. Okay, now we have set up all the background layers, but let's focus on the survey layer. So we have a survey layer here, and if I go to the attribute table, I see it comes with a feature ID, date, nodes, photo, and we need a lot more for our mapping project. So I'm going to add a few more attributes. Let's save the project before we continue. And so go to editing mode, and I'm going to add a few new fields here. With this button, you can add new field. And what I would like is observation number. And it can be a number or a text or a code, what you want to fill in. I will, let me just put here a text string. So you can use codes for different kinds of observations. And you can add here a length of that code, how many characters. So put it on 10 characters. Okay, let's add another one. I would also like to know the observer name. It should also be text. Let's put that 20. Then I would like to write down the land cover. And we're going to code that with numbers. I'll show you later how we link numbers to land cover itself. So this will be integer. Then I would like also to have an indication of the crop type, if it is a crop. So I'm going to make a field called crop, and we also do that with numbers, where different numbers are different crop types. Then I would like to know what the water source is. And we also do that with numbers, if it's rain-fed, irrigated, or whatever. And then another one that I want, if it is irrigated, I want to know the irrigation method, called method. And I also code it with numbers. And finally, I would like to know the coverage of the vegetation or of the crops. And I want that as a percentage. It's a decimal number. So I call it decimal number here. And I want one more field to make notes. That should be text. And it should be a bit long, maybe 500 characters or something. Okay, then I save my, oops, cannot commit changes. Interesting. Okay, there's one problem with that notes one. Let's go back. I didn't test that exactly as I did here, of course. Probably notes is too long. Leave out the notes then.
No, it's already exists.
Sorry. Yes, thanks. Which is obvious. Yeah, it already exists. Thank you. Okay. Thanks a lot. So I save. I'm still. Notes. Hey, seems to be something wrong. Let's remove ops number now and see what went wrong there. Seems to have some issues. Hey, let's save project and retry this part again. Okay, it's all there. I'm not sure why it went wrong. Probably I confused it by giving the same name for nodes. Okay, but this doesn't look really useful to have such a list. So what we're going to do next is create the widgets. So click right, and you can go to the properties of your layer. And there you can find attributes form. And this is where you can create widgets. And I'm going to change this here to drag and drop designer. I'll show you how this works. So here, this will be our form layout. And what I would like to remove is the FID. I don't want that in the form. And I want to start with the observation number. So I move it up. And then the date. We can have the nodes at the end. Photos, okay, name, land cover, crop, what source, method coverage, yeah. And now for each of these fields in the attribute table, I can define the widget. And with the alias, I can type what the user will see on the phone or in the attribute table form view, which I'll also show you later. So this will be observation number. And text, that's okay. And I want it to be not null. So it needs to be filled in and it needs to be unique. Then I go to configure date. And it will already recognize that it needs to be the date time format here. And I'll write here as an alias date with a capital. And I would like to have the display there custom. And I would like to have it in a different format, not in the US one. I want day, month, year. And here you see then the preview. The user can get a calendar pop-up. And I also want it to be filled in, mandatory. And I want that it automatically fills in the date that we have now. So I use $now, which is the function for current date. And then I go to a photo, and this has already been configured in this project. And what is important if you add it manually in your project is that you use widget type attachment. So here you see many different widget types that you can use. And for photos, we use attachment. Like for date time, we use date time, and later we'll use value map. And you see that it also has to be set to relative to project path. So what will be stored is the link or the file path to where the picture is stored. And then this widget takes care that, oh, it finds it there, so it has to display it. And it displays it in an integrated document viewer. We'll see later how that works. I'm not going to enforce the picture, but I'm going to change the name to picture. This is observer name. And I think it should be above there, so I move it here. And that's also text. And it should also be filled in, because it's always important to know who has done the field work and collected the data. So if there are any questions, you can ask. Then we are at land cover, and I want a drop-down menu with different choices for land cover. So as an alias, I put here land cover, and this will be a value map. And I'm going to code them that for land cover value 1, which will be stored in the table, but to the user, it will be shown that it is cropland. For 2, I do tree cover. For 3, I do shrubland. For grassland, you can use this time to catch up a bit if you're following. 5, I choose wetland, and then you just use a few of these ones. 6, artificial. Oops. 7, bare soil. Made a typo here. 8, fallow land. 9, seasonal water. 10, permanent water. Wrong line. Okay, so a user will see this in the drop down, and it will store the number in our table. And I will not enforce this, but this is of course important, but just to show you also that you don't need to enforce all the things. Then I'm going to go to crop. And for crop, I'm going to do the same. I also want a value map. And the alias here is crop type. And there I'm going to use for 1, wheat. For 2, maize. For 3, rice. For 4, barley. For 5, soybeans. For 6, pulses. For 7, cotton. 8, potatoes. For 9, alfalfa. And the last one here on my list is sorghum. Now there's only one thing I would like to include in my app, is that people can only choose the crop if the land cover is cropland. So I'm going to add a condition. And I can do that with an expression. With this button, you can go to the expression editor. And here you can find all the fields that we have in our attribute table. And this one should be land cover equals, and crops was 1. So that should be then the restriction. So I type here only for crops. And I can enforce that constraint. So you can only use that drop down if you've chosen crop. If you've chosen other land cover, you cannot choose the crop type. Okay, then we go to water source. And also that is a value map. And there 1 is rain-fed. 2 is irrigated. 3 is irrigation, and 4 is unknown. Now, in this one should only be available when it is when it's a crop. So same. So here under recent, you can find what you had earlier. So you can just fill it in and enforce that constraint only for crops. Then we go to irrigation method. Same story. So value map. So I need to fill in the alias for the user, irrigation method. And then 1 surface irrigation, 2 is sprinkler, 3 is drip, and 4 is unknown. And I want this only to be filled in if the water source is irrigation and if it's crop. So both conditions need to be true. So I'm going to make a new condition. Land cover equals 1 and water source equals, and then that should be 2 for irrigation. Yeah. And we want that to be enforced. So only for irrigated crops. Then we go to coverage. That is vegetation cover or crop cover. And widget type, we can use a range. And the range should be from 0 to 100%. And maybe you can make steps of 5. You will visually check the coverage, and going really to a percentage is very difficult. Even 5% is difficult. So that looks all okay. And then notes, right here, notes. And this can be a multi-line text, and that all looks okay. So click OK, and I'm going to save the project. Now, how does that look like if I go to the attribute table? In the attribute table, you have a form view and a table view. You're used to look at the table view, but if I go to the form view, I don't have anything added here, but you will then see those widgets. So let me just for fun or to test, just add a point, which we're also going to delete later. I'm adding a point, and then I get this form, and there are all these drop downs and constraints. So this all looks quite good. So I think we are ready. There are just a few more little settings we need to do. I go to projects and then to properties. Then you find here Mergin Maps at the bottom. And there are a few settings you need to know about. There is enable selective sync for input. So this is for the mobile phone app. If you are working with a team and you're in the field and you want to synchronize the device, you don't want all the pictures that other people collect using your bandwidth and your bundle. So with selective sync, it's like with Dropbox and other cloud services, you can only synchronize your own materials and I mean your own pictures, and not having the pictures of others download. So you can check that box if you need. You can also downsample the photo quality, because maybe modern phones will have very high resolution. So you can make it much smaller. And there's some snapping settings if you are dealing with digitizing inside the app for lines and polygons, which we are not doing in this case. Another thing that is important is data sources. This gives you all the layers. And we need to distinguish between survey layers and other layers. And you can have multiple survey layers, and they can be points, lines, or polygons, but you need to, for survey layers, always indicate that they are not read-only. And if you have other vector layers that are not survey layers, you have to put them on read-only, then they cannot be seen in the app as a survey layer. So that's important. Survey layers always need to be unchecked for read-only. Then there is another setting. Let me check where that was. Oh, here, view settings. That's also an important one, because some of the layers cover the whole world. And if you do zoom to a project, then you will have a world map in the field, and that's not good for your bundle, but also you need to take time to find back where you were. What you can do under view settings is to set the project extent. And you can use the map canvas extent in this case. So when in the app will later do zoom to extent, it will zoom to this extent, and also in QGIS in my project. So this also works, of course, for your normal QGIS projects. I will demonstrate it. So if I zoom in here and I would now click on zoom to full extent, then it will stick to the boundaries and it will not go beyond to the whole world. And this, by the way, the offline layer, therefore it doesn't show the whole world. But to prove that, go here to the satellite online and you'll see the rest. But if I click this button, it will still go to the extent of the study area. So I think these were all the settings. Let's save it. So it's time to hit the Synchronize button and get this project in the cloud. Okay, and this warning is normal. So you see what it's going to upload. And you see what it's not uploading, and these are all our raster layers. So these are the other things. So I sync. So it's now pushing this whole project to the cloud. And now I can see that on my mobile phone, hopefully. So let's go to the mobile phone. And there I go to my projects, and there I can find this new project here, tagng, and with this button here I can download the project to my phone. So with synchronizing, the first time takes time because it needs to transfer all the files, but once you start mapping and making changes either in QGIS or on the mobile phone, it will only transfer the changes. So then it's very efficient. So I can click now on the project and it will now open the project, and this is where we are. So I'm now simulating that I'm there. I'm spoofing my GPS signal. So in the interface, let's see, there's a question. Can we define a sample grid before go to field and use it as a reference for new data registration? Yeah, you can put anything that you can put in a QGIS project in the map canvas and use that in the app. So I can also add vector layers, and I can add labels and can use the styling. Didn't show that yet, but you can change the styling of everything. So indeed, there are things that you can add to your mapping project that help you in the field. Maybe have a layer with parcels. So here in my mobile phone app, I can see here the GPS accuracy. If I tap on it, it will give me the GPS info, in this case from my mobile phone, which is using spoofing. So these are not real things that you see, but in your case, you will see the real stuff. What you can also do is, you see here GPS and that the signal is green. You also see that here. That means that it is below a certain threshold that you have defined. So if I go here to more, then I can go here to settings. And there I can choose thresholds for the GPS accuracy, which it will give with those colors. So now the accuracy threshold is put on 5 meters. So you are warned when the accuracy is not enough. There's this setting, follow GPS with map. It means that when you are moving, it will automatically move the map, like you also have at Google probably. You can also add an external receiver. Now I use the internal one, but if you have a Bluetooth GPS, you can connect it here. For lines, you can record that. If I click here on GPS, it will center around the GPS. And if I go here to more, you will find here zoom to project. So now it's back to the zoom level. So this was centering. And what you can see here is map themes. And there you recognize what we made. So if I would like now to use Openstreetmap online, I choose this one and it switches to Openstreetmap online. And if I now want to choose the offline actual evapotranspiration, and I'm here. So this is what you can do. You can also zoom in and see where you are. You can also use the offline satellite image. And then you want to collect a point. It could be that you are not exactly in the field because there was a fence or something. But if I want to record a point, I click on record. And it shows me a different icon now on the screen. In orange, you see still the GPS and in which direction I'm looking. And then you see this crosshair. And I can still zoom in a bit more. And I can move to where I want to put the observation. So if you have a fence or there's a big bull and you cannot go to the center of the field, you can manually move the point to where you want it. And here you'll see then the list of the survey layers that you have. In our case, we only have one. So I just click add, and I can start adding a point. So first I add here the observation number. This, I can use text, so I call this A1, server name, once the date, it chooses the current date and time. So, okay. And I can take a picture. Let me do that. So you can now see what I see on my screen. And oh, it's complicated. Take the picture. And then I say, okay, I rotate my phone again. I have a picture here. Then I can choose the land cover. And here you see already that you can only use it for crops. It's not really enforcing it, but I can choose here. Yeah, I think in some other settings I've seen that was enforced, but at least the user is informed. So for crop, I can choose here then wheat, water source, choose rain-fed. Then I should not be able to fill this in, but it still fills it in. I think I've seen that differently. Choose here different things. And then the vegetation crop cover. I can use a slider and I can take some notes, demo. And when I'm done, I can save. If I still want to move the point, I can click here, edit geometry, and I save. And now the point is there. Now we want to see it, of course, also in QGIS. So I'm going to synchronize. Let's move to another point. Let's do another one. Let's take one here. Fill in the date. So if you click on this, it automatically takes it. This time I'm not gonna. Oh, let's also take another picture. Let's do a selfie. You look like a crop. Okay, now I'm going to do seasonal water. This I should not fill in then. And this also demo. And then I save it. Oh, required field not filled in. So which one was the? So you see that it responds to that. So observation number, that is A2, server name, once and then I can save it. No, still a required one. Maybe I'm not sure. Always good to test these things. There can be little mistakes. It says an unmet constraint there. Don't know why. Okay, something goes wrong with the date and time. I need to fix that. So let's cancel this one and then synchronize it back. So yeah, while making this, you need to also, of course, try and test and synchronize until it's optimal. In a live session, I can make little mistakes, of course. When you look at my YouTube channel, then they are, of course, cut out. Now I synchronize the project and it says successfully synchronized. So now it's in the cloud, and now I'm going to pick it up here in QGIS and see where our point is. So I can also click here on synchronize, and it shows me the changes. The picture was taken, but the data was not saved, but the picture is still there. That's what you can see here. I click on sync, and it's successfully synchronized. And here's our point. Now we, of course, want to see a point. So I go to attribute table, and here I see nicely in the form view all the data that I've collected. So this is what you can do. I see a question from Johannes. Can we link data recorded with QField to Mergin? I'm not sure how compatible it is. They both use QGIS. So what you can do is, if your project is in QGIS, create a Mergin project out of it and use that in Mergin. But you cannot collect data with QField and synchronize with the Mergin infrastructure. They're two different products, two different infrastructures, but they both use the QGIS engine in the backend. And in the table view, you will still see then these things filled in. Now, there's more stuff that you can do. If there are any questions, please let me know. So what you can do if you change anything, like let's say we move the point from here to there, then we have changed something. If I click here right on survey, I can choose here show local changes, and it shows me that there are changes. Survey. I've just seen this today in Saber's webinar, so it keeps track of all the changes. And if you have multiple points, it shows you which have been deleted and which have been added. So there's a question from Andre Sanchez. If we want to use the same point to collect time series data. I'm not sure if that's possible, because the temporal dimension is only included per feature. So every feature has a timestamp, but it should be a new point. But it could be a nice feature that could be requested if there's a need. Mergin Maps also comes with tools in the processing toolbox. So what you can do is create a difference file. It will compare different versions of the project. You can make that. You can also create a report of all the changes. It creates a CSV file with all the changes, and also extract only the local changes. And it gets this information also of the differences with the versions from the cloud service. And let's have a look at that. So I'm going here to Mergin Maps. So this is the website, merginmaps.com, where you can, if you have an account, you can also go there, and then you can log in. And there you'll have your dashboard, and you will find here your projects. And here is our new project. It's 14 megabytes in size, updated 3 minutes ago, because I didn't synchronize the last one. And here you see all the files that are in the project. So what you can do is download these files. So you just download it from here instead of synchronizing it. You can also add files here by dragging and dropping. Here's the map functionality, but that's only if you have a pro or team subscription. I've seen it today in the webinar by Saber Rasm Dewey. It looks nice, and there's a lot of other things coming up, but then you can also almost real-time follow the people in the field who submit the data and see the changes of the data in a nice interactive map. The history tab is important because there you see all the different versions. And I moved that one, so I can synchronize that one again. Okay. Then I go back and can refresh this. And now we see version 4 there with 1 point edited. Click on it. You can see who has done it, the date and the time, and the client. So that's my Windows computer. And here under modified, you see then exactly which layer has been modified. And here you see also that this point has moved from one coordinate to the other. So you can keep track of a lot of different things. You can clone the project if you want to use it for another project. And here in settings, I can add other users. So if you have an account, then I can invite you here by just typing your name and adding you as a reader, as an owner, or with rights to write. And you can also ask for a request for access. So this project is public, so you can find it also in your, if you browse to the projects. I will show that in a bit. You can also make it private. You can transfer it to another person, and you can also delete it if you are extending your amount of space. So here, my projects gives you all your projects. Shared with me is, of course, project shared. And Explore gives you access to all the public projects that are available in Mergin. And that's the same on your phone. So if I go here to, if I synchronize it first, because there were changes on the server. So I want to that moved point. So now it's here. You see how fast it is now. It just only needs to make the transaction of the changes. Go back to projects. And you see here different icons. This means it is on your phone and can be uploaded to the cloud. This means it needs to be synchronized, and the ones that have nothing, like our, where is ours? This one has nothing, so it means it is in sync. So that's good. So that's these are the projects that you have on your phone. That's under the home button. My projects are all your projects that are on the cloud. Shared with me is again shared with me, and Explore, you can find all the public projects. And what you can do after this webinar is look for this one and get it on your phone and try it. I think that's all I wanted to share. No, there's one thing more, if you want more, because there's a lot of cool stuff you can do. Let's go back to the Mergin Maps website. There's a very good documentation. And what you can do is check out other things of setting up the project. For example, if you want to read about making these background maps in a different way or using map themes, you can find it here. About configuring the survey layer, you can also use the EXIF data, that is the metadata in your photos. And I have a video about that, how you can create a wedge buffer that shows you the direction in which you have taken the picture. It's a bit too much for today to do it, and there's already a nice video about it. So I think it's very useful for crop mapping, especially if you cannot really enter the parcel, that you take the picture and it shows you which direction you have taken the picture, and it takes it from the metadata of your from your phone, how it stores the picture. So it's in the EXIF metadata, and there are these functions, they can be used in QGIS. You can also have multiple pictures per point, and then it creates a 1-to-n relation. That's also something you can do, and you can add non-spatial tables. So very nice and flexible tool. If you want to learn more about Mergin Maps, and then there's also the GIS Open Courseware website. There's where I have all my open courses. They're all free to use. You just need to click on a button on a course. You don't need to register. And there's here some on input. So they have rebranded it. So the tutorials are a bit older, but the principle is the same. So you can find here all kinds of tutorials and videos related to merging and input. And then there is my YouTube channel. And there are some recent videos demonstrating those wedge buffers if you want to know more about it. For example, here you can see how to add those wedge buffers and the result. See if I can show that. Here, so that will look like this on your phone. So the direction you take the picture, it will create the wedge buffer. So there's a video about that. That was all. Are there any questions?
Okay, do we have any question in the chat? You have your microphones locked, but I can allow you to use it if you ask in the chat. Okay. So if you do not have any more words, Professor.
Sorry, Sanchez.
Yes.
There is a question from one of the participants on Facebook.
Okay. Do you want to read it, please?
Yes, I will read it out so that the professor can actually hear. So the person asked a question. Can these water productivity map layers be applied in forestry in calculating water evapotranspiration in leaves or trees?
Well, it gives you the actual evapotranspiration and interception and all kind of other variables that you can use for many different purposes, so not specifically for crops, although it has been designed and probably optimized for that in case of the algorithms that are used. But you can also use it for other purposes in water balance calculations. But to go to the level of leaves, that's not possible from space with this data set.
Thank you, Professor.
So if we have no more questions, I will, in first place, thank you for your presentation. Very informative and very okay. To be, I was very excited about your presentation today about your training. And I actually talked. So for me, it's very important to have tools to get data from the field and synchronize it automatically to the computer. And the solutions in the market, we are talking about thousands of euros. Mainly Esri, as you perfectly know. And have today you in about 1 hour and a half showing us a free solution, very efficient and very fast synchronizing and user friendly. I think it's very important for our trainees and for the world, because our training will be public very soon. So today you did a really important impact, I think, and it was what was expected. And you have a very appreciation from us. I also saw a lot of new people in our training today. So your presence is very important in this way too. And now, as we say to our professors and our invited professionals. You are part of the tech family now, and this is very important for us and for all our followers. I'm sorry about my voice. I'm a little bit sick today, so this is not easy. But again, I don't know if you want to say something, Professor. It was a real big pleasure to have you here today. And thank you for all the knowledge that you have, and you allowed, and you had this attitude, this good being of share with us for free, and just thinking about impact and the change that you can do in our followers' lives. Thank you very much again. I don't know.
Thank you for the nice words, and I would also like to thank all the participants. I also see familiar faces from many places where I met people. I see colleagues, I see students that I've been also teaching today. I've seen other people I've been in touch with, so thank you also for joining. I'm very honored that I was proposed to you by Quisheng Wu, so also thanks to Quisheng for linking me up with you. And I think keep up the good work that you are doing, and I'm happy to be part of your family in that way. Thank you.